If you find expected goals confusing, you're not alone. In fact, they're lying to you. It's on ESPN, FIFA, and every football YouTuber and their grandmother worships this thing. But of the last 170 Premier League games, Total XG correctly reflected the final scoreline 16% of the time. So why is Total XG so inaccurate? And if it's such a terrible predictor of the final score, why do we keep using it? This is the story of the most well-marketed yet misused sports stat of all time. In this video, I'm going to delve into what Total XG actually means, why we use such an inaccurate stat, and how we should be incorporating XG correctly to improve our understanding of football. Total XG is what we often get during post-match analysis coverage to highlight which team played a better game, and we get this number by adding up all the XG values for each team. But spoiler alert, it's not something you can add up without losing some information. XG is the expected probability of a shot resulting in a goal, so if a shot takes place over here, the XG model might spit out a value of 0.4, which means if this action is repeated 10 times, we would expect 4 of those to result in a goal. But that's not exactly what we observe on a game-to-game basis. Initially, I wanted to make a bot to scrape the total XG values from XG philosophy, but it turns out Elon Musk started charging $100 a month to do this, so being the Excel monkey that I am, I started hammering away. And what we find is pretty interesting. When the total XG is rounded to the nearest whole number, it's able to predict the final scoreline 16% of the time. That's literally a roll of a dice. And when it's presented like this after every big match, it suggests a false narrative. If we zoom out a little bit more and look at how well Total XG predicts the game outcome, we see that it's slightly better than a coin toss. So why is this the case? It's because the XG model only really works when 2 conditions are met. First, we need observations to be independent of one another, and second, we need observations to suggest our findings are not skewed by outliers. Let's take, for example, a sport like baseball. This is where the moneyballification of all modern sports began, and for good reason. Baseball is complex in its own right, but compared to a dynamic sport like football, it's pretty static. In many ways, it's like a Pokemon game. Every play starts out with a pitch, and a batter who consequently reacts to the swing. There's a finite set of outcomes that can occur, but the initial setup of the game is always controlled. Teams definitely employ strategies based on game states and player matchups, but for the most part, a pitch from the second inning is unlikely to affect a pitch in the 6th inning, so the assumption for independence is pretty strong. On top of that, the average Major League Baseball game has around 300 pitches, which means 300 observable data points that meet most standards for the law of large numbers. Analyzing football is much more like trying to envision Pokemon, not from the lens of a turn-based game, but as a dynamic battle between 2 living monsters. It's more about the dance between 2 teams, and less about the decisions categorized as individual shots or passes, just in isolation. When we look at football, we're observing an average of 26 shot attempts per game, of which around 9 are on target. In most cases, this isn't enough data to give a confident prediction from the XG model. The lack of game-changing actions observed in football means that luck plays a big role in the outcome of games. On top of that, shots in football can't confidently be categorized as independent. Take, for example, Bruno Fernandes, who attempts a long shot in the 10th minute of a game. Whether this goes in or not, the next time Bruno gets on the ball in this situation, the opposition will react differently. If they give him too much space, he can go for a better long shot, and if they try and close him down, this provides opportunities for him to find his teammates. The last reason Total XG is a bit sacrilegious is because adding XGs can sometimes paint a picture that wasn't there in the first place. If we accepted the fact that all of the shots in one game were independent and we had enough observations that wouldn't skew our results, then we have an argument to add these values together. So let's take, for example, 2 teams that both have a total XG of 1.0. Based on this presentation, you would assume that it was probably an even game. But what if I told you that the constituent XG values were the following? Would this change your opinion on who had the better game? Or rather, who deserved to win the game? Perhaps. Aside from the fact that this is an extremely reductive way to analyze an exciting sport, some of us might prioritize higher quality chances, while some of us may value the possibility of scoring more goals. So what does the math tell us? To analyze this, we can look at the possible goal outcomes for each team. Let's start with Tottenham. Tottenham recorded 2 0.5 XG chances, which tells us that they could have recorded anywhere between 0 and 2 goals in this game. the probability of them scoring 0 goals is equivalent to the chance of them missing both of them. Here we get 25%. Now the probability of scoring 1 goal is equal to the chance of scoring 1 and missing 1. But in this scenario, we can get an outcome of 1 goal scored if the first chance is scored or if the second chance is scored. So we have 2 ways of getting to this outcome. Here we get 50%. Lastly, the probability of scoring 2 goals is equal to the chance of scoring both chances, and here we get 25%. I'm not going to bore you with the derivation, but we can generalize our calculations with the following expression. Now let's take a look at Man City. City recorded 20.05 xG chances, which means that they could have scored anywhere between 0 and 20 goals. 20 goals is super unlikely, but you do miss all the shots you don't take. If we go through the same exact calculations, we get the following probabilities for each outcome. We notice that for both City and Tottenham, the highest probability for any of the outcomes is for 1 goal, the same as the number of expected goals. When total XG is thrown around by pundits, this is what they're referring to. But as we can see, it's a really misleading statistic because the expected outcome is not the same as the most likely outcome. In fact, in any of these scenarios, there is no one outcome that has any good odds of being picked. So going back to our scenario, how do we determine who deserves to win? Since we have the discrete probabilities of each team converting their chances, we can find the joint probabilities for each of these cases and categorize these scorelines by a win, a draw, or a loss. What this shows is that if we run this game 100 times and we have the exact same set of chances from both teams, we would expect Tottenham to win 36 times, City to win 31 times, and have the 2 teams draw 33 times. From this, we can see that having higher quality chances gives you a slight edge, even if the total expected goals for both teams are the same. This might not seem like much, but margins are razor thin at the highest level, and over the course of a 38-game season, 1 or 2 wins might mean the difference between a title win and 3rd place. I'm still learning how to make videos, so if you got this far, thank you so much for watching. I hope this was helpful, and I'll catch you in part 2 of this series.